before getting into the main topic, let me first introduce some examples of how UE is being used in Japan. Here are some of the major titles were released on consoles using Unreal Engine. For example, Final and Pikmin and Hi-Fi Rush. Yes. Unreal Engine is often associated with photorealistic visuals. It has also been used in titles with non-photorealistic styles, like Persona. And as a unique aspect of the Japanese market, although the number of PC gamers have been increasing recently, consoles, especially Nintendo Switch and PlayStation, still dominate the gaming landscape in Japan. And moreover, many titles are not limited to a single platform and released across multi-platforms. And so strict optimization is required in many places. And Epic Games provides a wide range of tools to support multi-platform development. And these include various scalability settings, profiling tools, and even tools for automated testing and continuous integration. But as the developer relations team, we interact with many developers every day, and yet we still hear things like this. Our game is just 2 months from release, but it's running at 3 FPS on a certain platform. What can we do to make it faster? Pre-orders on Amazon have already started. And a platform's QA team came back saying, your game violates their guidelines. Isn't the engine supposed to take care of those kind of rules? If the game runs at low FPS, that's still manageable, but in the worst case scenario, it might not even fit in memory, and you cannot run it on the platform. Why are so many developers still struggling with multi-platform development? As I said, Epic Pro. And is it that these tools aren't well known? Or are they known but just not being used? How are most developers actually approaching multi-platform game development? So we conducted a survey across more than 15 projects to learn how developers handle multi-platform development in their day-to-day work. Today, I would like to share some of those insights with you. Unfortunately, many of the titles have yet to be announced. Although, rather than stories of here's how we succeeded, many of the responses were more of here's what we struggled with. So we won't be able to share specific project names, sorry. And we cannot discuss platform-specific settings or hardware specifications, as these topics may risk violating NDAs. And also, today, we won't cover mobile-specific topics either. But however, many of the insights shared today should still be helpful for mobile development, I believe. All right, let's get started. This is today's agenda, and we are just about done with the introduction. But before we move on, let me quickly introduce myself. Who am I? I'm Nori Shinoyama, Customer Success Director at Epic Games Japan. I have been working at Epic Games Japan for more than maybe 9 years. And before Epic, I worked at Sony as a graphic researcher. And completely off topic, but I have an international sake sommelier license. So if you come to Japan and want to have sake somewhere, feel free to reach out to me. I can introduce you to the bar or restaurant serving great sake. And I had the same thing at the last year's Unreal Fest Gold Coast, but give me 1 minute. Yes, please give me 1 minute to show you Button Girls. I know the K-pop is super popular all over the world, but I really want everyone to know about J-pop idol as well. The Button Girls group is a very unique Japanese idol group that combines Japanese old traditional music with current dance music. Actually, they are a singer of an ending song of Dragon Ball anime. Yeah, I would appreciate it if you took a look at them. Seriously. All right, that's enough of a detour. Let's get back to the main topic. To start, I would like to talk about what I believe is the most important general guideline based on the results of the survey. That is the mindset about profiling and optimization. Okay, how many of you enjoy profiling and optimization? Personally, I feel pretty neutral about it. But that said, regardless of whatever you like it or not, as long as game runs on hardware, profiling and optimization are unavoidable, no matter how advanced the hardware becomes. And when developing for multi-platforms, it's ideal to make use of CI and other tools to continuously measure performance across all platforms from the very beginning of development. But it turned out that many licensees, many developers in Japan only start optimization in the later stages of development. Yes, that's when the struggle began. And let's walk through a few failure cases that should be avoided. The first example is the most obvious one, not testing on actual hardware until the very late stage of development. Developer build everything on a powerful PC and create trailers, then announce the release date on all platforms. While extreme cases like this seem to be decreasing, but they still happen. For instance, internal or publisher approvals are often done using only their PC build. So we all know exactly what happens in this situation, so I'll spare you the details. The next pitfall is one we occasionally see, to avoid the hassle of long builds and cook time for each platform. Some teams try to simulate target platforms by running the game on a PC that matches the CPU, GPU, and memory specs for each console. Actually, this approach is completely meaningless and absolutely not recommended. No matter how closely you try to match the specs, you can't replicate the actual environment. OS, drivers, SDKs, all of them are completely different. And most importantly, Unreal Engine 5 code itself is also different per platform. UE5 performs various low-level optimization, tailored specifically for each platform. Given all these differences, using a PC build to simulate and test other platforms is simply incorrect. Okay, here's an example where the game is actually tested on real hardware, but unfortunately, it's still not a great approach. To avoid the hassle of testing across multi-platform, some teams only test on the highest spec platform and feel reassured when it runs well there. Yeah, sure, it might offer like a psychological comfort, but it does nothing to guarantee performance on low-end platforms. As when we point this out, people often respond with, we'll just lower the resolution and LOD settings for the lower spec platform. But no, it's not just about graphics. If the game doesn't fit in memory, it might crash before it even renders a single frame. If the I/O is too slow, the experience could become frustrating and unplayable. And now let me share another type of failure case. Do you enjoy optimization? Yes. As the final failure case, I'd like to highlight this. Relying on editor tools to optimize without thoroughly checking performance on actual hardware. Have you ever come across optimization tips like this in like a YouTube tutorials or blog post or Twitter or something? Like check the resource monitor or content browser and reduce the resolution of unnecessarily large texture. Or look at all those raw codes in the stat view, time to cut them down. Another example, like, the instruction count in the material platform stat is super high. We should optimize that. and shader complexity view. Actually, this is the material mask used to create cutout leaves, but if you look closely, something seems a little off in the shader complexity view, doesn't it? Okay, I'll be sharing more of these kinds of graphic-related insights in my session this evening. Yes, if you are interested in the graphics, yes, please come to my session, another session. Okay, this might be the most important message I want to share in this session. Stop optimizing without profiling on actual hardware. There is a lot of information on optimization in the world. Polygon, text resolution, shader complexity, but they may not be effective for your project. Make sure profile before doing any work that reduce the quality of the a graphic or takes up the artist time. You must regularly profile your game on your target platform. Yes, we've looked at a lot of failure cases, but let's take a look at the success story too. Of course, the idea is to check performance on all platforms, but if that's difficult, how about using the lowest spec platform as your baseline and verifying gameplay, smoothness, and graphics quality there? In fact, several developers in Japan have adopted this approach, and they are saying that it worked extremely well. It appears that this method was particularly successful for titles that weren't aiming for hyper-realistic or high-end 3D graphics. They say that by focusing on the lowest platform early on, they avoided major issue with memory, loading time, and gameplay quality in the later stage of development. Then, for the high-end platform, they were able to simply boost internal resolution, improve shadow quality, and make the straightforward adjustment to enhance the visual quality without any major headache. Although it requires more effort, there's a solid method because every platform differs in terms of memory, CPU, GPU, and so on. You can first estimate the likely bottlenecks for each one. Then implement automated tests that run nightly or at regular intervals to track those areas. Yes, and this insight doesn't come from Japan, but I would like to share a really valuable video on graphics performance testing. It's budgeting in a post-poly count world by Firesprite presented by at last year's Unreal Fest. The session gives a clear and thoughtful explanation of how to properly test and evaluate GPU performance in today's super complex and highly asynchronous rendering pipeline. I believe the content is relevant and important no matter what type of game you're making. So I highly recommend checking it out. Also at 2:30 today in the menu room, my coworkers Ken will be giving a talk titled Mastering Performance Analysis with Unreal Insights. Be sure to check it out as well. So this is a summary about profiling and optimization. Ideally, all platforms should be monitored, but many developers still fall short of this. Neglecting checks on each platform will come back to hurt you in the later stage of development. Yet even now, many developers continue to make this mistake. And don't become the optimization police. Profile on actual hardware. If the requirements are met, you don't need to optimize unnecessarily. And follow the requirements of your team and your game, and check each platform as thoroughly as possible in early stage. Before we move on to the next section, here's a quick tip. I asked several Japanese developers how they determine the minimum PC specs for their game. Many say that publisher decided, but and then the game design is adjusted to work within those minimum specs. But a common approach is to refer to the Steam hardware and software survey, which is common approach, which give us insight into the typical hardware users running. And some developer and also set the Steam Deck as their minimum spec. And in particular, for games that use high-speed streaming features like nanite or world partition, SSD may be required. So be sure to evaluate the requirement early on and make informed decisions about which technologies to adopt. Okay, the next session will be much shorter than the last, but I would like to take a look at the technical side, how developers are actually checking and validating each platform in their day-to-day workflow. Yeah, as I said, in an ideal scenario, CI runs every day, nightly builds are generated automatically, and automated build validations and performance tests are executed. With all the results reported back in a clear, beautiful format. Yeah, fully automated system. And Epic offers a powerful toolset called Hold. I hope my pronunciation is okay, but Hold, that helps make this kind of workflow much more manageable. Yesterday, Jack gave an excellent talk on Hold. If you haven't seen it yet, be sure to check out this in the archive. And also, Matt gave another excellent talk on automated performance testing. Be sure to check out this archive as well. So, how many of devs are actually running CI across multi-platforms? Yeah. To be honest, it turned out that fewer teams were running these workflows than I expected. Of course, there are company developers that had full CI pipeline testing every platform daily, but there are also teams relying almost entirely on manual testing. The fact, in every case I spoke to, developers were at least generating nightly builds for each platform. And here's a quick tip. Let me share a breakdown of the tools used by the teams who were running daily CI and automated tests. Still, almost all of the team were using Jenkins as their CI system, and they leveraged it to automate build and cook testing. Performance testing, rendering output comparisons to catch measure visual changes, and even performance measurement through automated play testing. And for automation, some teams use Gauntlet automation provided by Epic or Unreal Engine. However, in larger companies with dedicated testing teams, they often had in-house automation frameworks and integrated those systems into Unreal Engine. And for visualization tools, Kibana seemed to be a popular choice. For lighter setup, some teams use Epic's own tools, CSV Profiler and Path Reports tool for analyzing and reporting performance data. Path Reports tool is a lightweight performance reporting tool provided by Epic. It allows you to visualize performance data directly without needing to integrate with any external services or applications. So if you are just getting started with performance testing, this tool is a great place to begin. And what are the reasons why some teams aren't using CI? The biggest reason is limited staff and resources. Yes, in smaller companies or with smaller scale projects, the human cost of creating, maintaining, and monitoring the test makes it difficult to adopt CI proactively. In large companies or on big projects, there are often dedicated CI engineers assigned full-time to the project, or CI specialists who oversee multiple projects across the company. So ideally, CI should run, this is a summary, but ideally CI should run across all platforms, executing a variety of automated tests daily. However, achieving this level of setup is something mostly seen in larger companies, while CI and automated testing are highly effective at reducing manual labor, but maintaining such a system does come with a certain cost. As a result, smaller projects often end up abandoning the idea. But don't forget, Epic provides a wide range of features to support CI. Up until now, we've talked about the overall workflows and high-level operations. From here, let's take a closer look at the specific multi-platform features available in Unreal Engine. Unreal Engine offers a variety of tools to support multi-platform development. Let's go through these features one by one and take a look at how developers in Japan are actually using them in practice. First, we have scalability. Unreal Engine provides 5 levels of scalability settings for various graphics. Features: low, medium, high, epic, cinematic. These can be adjusted dynamically through the editor or via console variables in runtime. That's why the system is commonly used not only for consoles, but also for the graphic settings on PC, such as like in-game quality options. What exactly does each scalability level control? That's defined in the scalability.ini.ini file. For example, this is a setting for shadow quality when set to epic. This .ini file can be overridden per project, allowing you to make detailed custom adjustments to meet your specific needs. One important caveat is that the setting within scalability can change with each engine version update. So Epic continue refine these settings based on learnings from real-world title development, as well as like improvements and optimizations introduced in newer version of Unreal Engine. So if after upgrading the engine, you suddenly notice you suddenly notice that the visual looks different or performance has changed, your first step should be to check whether there were any changes to the scalability setting. And scalability settings that apply through each platform's device profile.ini. You can also add additional console variables here to further customize behavior. This is a very fundamental part of Unreal Engine configuration. And in our survey, every single project used a combination of scalability settings and custom keywords in device profile.ini to define platform-specific behaviors and optimizations. Scalability is easy, but next up is preview platform. Did you know Unreal Engine includes a feature that lets you preview different platforms directly in the editor? By enabling this, you can see the rendering result as they would appear under the setting defined in device profile.ini, like including scalability and platform-specific overrides. This feature was updated in Unreal Engine 5.6 and now includes texture streaming and texture group preview support, and bringing it even closer to how the game would actually run on the target platform. And everyone I talked for this survey, they knew about this feature, but yes, unfortunately, almost no one was using it regularly. There were 2 main reasons. It's difficult for artists and other team members to manually check the visual results for each platform as like part of their daily workflow. And the emulation doesn't actually reflect performance or rendering load. So in the end, they felt they had to rely on testing directly on real hardware. But that said, when it comes to mobile development, where you need to check multiple resolutions and aspect ratios, maybe this feature may be much more valuable option, I think. Next is material quality switch. This feature allows a single material to adapt to different scalability levels. For example, when scalability is set to low, you can skip heavy calculation entirely, while for cinematic, you might include high-cost functions for maximum visual quality. And similar feature also exists in Niagara. Niagara Scalability, you can access it like by just clicking the scalability icon in Niagara Editor. And the scalability setting window will open and allowing you to configure individual values for each scalability level. So as you can see, Unreal provides functionality to adjust assets based on scalability. But how have these features actually been used? Yeah, same situation. Almost no one was using them. Yes. Next, did you know that there is also a feature called platform override? Sorry. Available for static mesh, skeletal mesh, and textures. For example, you can configure the minimum LOD per asset for each platform and adjust how quickly LOD transition occurs. Okay, next, same question. How have these features actually been used? As you can imagine, almost no one was using these features as well, functions as well. Nearly all of the 15 projects we spoke with weren't using these features at all. All features were recognized and known, but most teams share the same sentiment. We don't want to adjust things on a per asset basis for each platform. Yes. And the general preference was to use broader settings like scalability. For example, managing it through scalability settings or like device profile. But some projects did make use of Niagara scalability, like disabling heavier emitters like light emitters, disabling a distortion effect on like lower end platforms. And also about platform override, this feature is also so limited usage. Same reason, we don't want to configure settings for each asset individually. Yeah. But feedback from those who did use or tested it, like maybe mean LOD only work for background assets, or actually they wanted to adapt it but couldn't because LOD there was still required for cutscene on all platforms, like even very super low spec platforms. And actually, the case they use, a developer used only for UI textures to differentiate between 4K platforms and the others. Also, at the beginning of today's presentation, I showed a page like this. I mentioned that the game can sometimes be rejected by a platform holder if the game violates their guidelines. And that's why it's important to check in advance whether your implementation complies with each platform's guideline and whether there are any specific issues specific to your game. So while Unreal Engine handles the basics, it does not guarantee everything for you. So you still need to verify the guidelines yourself. Platform holders won't accept excuses like, well, we are using Unreal Engine, so this is specification, so it can be helped or something like that. Yes. So this chapter may have sounded a bit critical of Unreal Engine, but Epic actually provides many features that allows asset level adjustment for each platform. But most developers were aware of these features, but they were used much less than expected. Many teams shy away from doing platform asset adjustment at the artist level due to concerns about cost and maintenance overhead. That said, there are projects making use of these features, particularly for cutscenes, UI elements, and special effects. Yes, using them in these focused high impact areas might be the most effective approach. Yeah. Okay, the last part. Let's take a quick look at multiple platform development with Nanite and Lumen. For example, let's say Nanite and Lumen are enabled on high-end PCs but you still want to allow gameplay on PCs that don't support those features. What kind of approaches are possible? To be honest, many projects in Japan are still actively working through this challenge, so there isn't a lot of consolidated knowledge we can share from Japan just yet. However, there are already some excellent examples out there, so I would like to introduce one of them. There was a great talk at last year's Unreal Fest titled Obscure Techniques for Better Development Experience and Visual Candy. Yes, it explains how to build scenes with and without Lumen, and showcases a clever technique for adjusting skylight using a simple gimmick. I often recommend this talk to Japanese developers, so I encourage all of you to check it out as well. In addition, there's a session coming up later today that I believe will be very insightful. I'm really looking forward to watching it as well. Yeah. That said, I know some of you may be attending other sessions at the same time. So in this session, I'd like to focus on sharing the very fundamental points you should keep in mind when approaching these topics. Okay, Lumen is a fantastic feature that enables real-time global illumination. But as you can see here, it doesn't just handle indirect bounces. It also accounts for direct skylight occlusion. In the image on the left, Lumen is enabled in a scene lit only by skylight. You can see how the skylight enters the room through the windows and soft shadows appear inside the room. And sorry, the screenshot was captured in a lightweight test environment, so there's some noticeable noise and artifacts, but okay. On the other hand, in the image on the right, Lumen is disabled. You might expect the scene to just be darker due to missing GI, but actually, the shadows disappear entirely because without Lumen, skylight occlusion is no longer calculated. As a result, objects are lit from all directions by the skylight, causing the scene to lose shading and contrast. So how can we handle this? If the scene is static, maybe the simple approach is just disable Lumen across all platforms and just bake lighting. However, okay, let's consider a scenario where dynamic lighting is required. This is our starting point. As you can see on the left, Lumen provides nice occlusion. And the question is, how can we achieve a similar result on the right without Lumen? I've moved the image with Lumen off to the left side for comparison, and by enabling distance field ambient occlusion, which requires distance field data, yes, it's achieved a stronger sense of contact between object and the environment. While we lose the directionality of light, such as like a skylight coming through the windows, but some of the lost shadows have been maybe, I can say, successfully restored. Here, we're using SSL, while it's more prone to visual artifacts than distance field AO, it still helps preserve some shadow detail within a lighter performance cost. And as you can see, by relying to some extent on techniques like ambient occlusion and carefully tuning post-process settings and skylight intensity, and you may be able to achieve a consistent look, even with Lumen turned off. So it's very important to adjust these settings to maintain visual coherence across all platforms. So here's a quick summary of Lumen. There are still many players using PCs or consoles that either don't support Lumen or can't run it with acceptable performance. In such case, you may need to rely on UE4 error rendering techniques to maintain visual quality. while Lumen tends to draw attention for its global illumination capabilities. One of its most impactful features is actually its ability to provide skylight occlusion. So reproducing this effect without using Lumen requires workaround and careful setup. Next, let's take a look at Nanite. On platforms where Nanite is not supported, a fallback mesh is used instead. A fallback mesh refers to the version of the mesh that is rendered when the Nanite mesh itself cannot be rendered using Nanite. And the fallback mesh helps by rendering a relatively low poly version of the original Nanite mesh. However, there are some caveats. If you have a large number of instances placed in the scene, or even worse, if your content includes many unique meshes or complex data, the traditional rendering used by fallback meshes can become a performance and memory bottleneck. For example, on platforms where GPU sync is disabled, automatic instancing may not be supported, meaning that Nanite meshes, just if you put a lot of Nanite meshes in the scene, might not be instanced at all. And since non-Nanite platforms lack pixel-based streaming like Nanite, having a large number of unique meshes can lead to significant memory pressure. Then using mesh streaming may help mitigate this issue. In the project setting under rendering mesh streaming, you'll find the option to enable mesh streaming, and it's off by default. And once enabled, you can configure how many LODs are streamed through settings in each static mesh asset or your LOD group. That said, to be honest, there are still very few examples of this feature being used. And at Epic Games Japan, now collecting use cases. So on non-Nanite platforms, Nanite meshes are rendered as regular polygon meshes via the fallback mesh. However, keep in mind, such as efficient handling of large instance counts and pixel level streaming of geometry will also no longer be available. So it's important to design your scene with these limitations in mind in your early stage. Yeah. Yes, that was a quick run through, but we've covered a broad range of insights from Japan, related to multi-platform development. Let me wrap things up with a brief summary. Yes, many developers are still struggling with multi-platform development, and building a perfect automated testing system is ideal, but it might not be realistic or difficult for your team. So let's find creative solutions that work for your team. And Epic Games offers a variety of tools for multi-platform development. However, users tend to avoid making changes at the asset level. And a game engine cannot guarantee that all game specifications and platform guidelines are met. So don't forget to check everything yourself. Also, while I don't have a slide for this, if you plan to use advanced UE5 features like Nanite and Lumen, make sure to test early on platforms where those features aren't supported. Okay, thank you so much for coming and listening. And I'm not very fluent in English, so I can't do Q&A here. But if you have any questions, please feel free to come talk to me directly at the Dev Lounge. And also, please check out Battengar. And most importantly, enjoy Unreal Fest and your time here in Bali. Thank you. ありがとうございました。ねえ